All right, let's get into it. So, yep, more exam revision stuff, or I guess exam practice stuff rather. This one's going to be the 2023 Tech Free we're going to have a look at. As I said the last time we did a Tech Free, the first two questions are always some form of diff or anti-diff, right? Like this one's just diffing a quotient rule, this one's a product rule, and then subbing in a point. I feel like it wouldn't be overly productive if we kept doing the same questions every one of them. So I feel like it'd be better off if I pick out the less common stuff, but still common enough to where you'd want to know it. That way, you're getting a bit more value out of the classes rather than just stuff you know you need to practice. Certainly. So probably from here on, we'll skip the question 1 and maybe question 2 of most tech free, just because they tend to be the same thing. And we'll just sort of take it from there. Starting with question 2. So, in fact, what I should probably do is give you guys a copy of the paper so you can do it at your own pace as well, because that way you can zoom in and see shit versus me having to try and get it all on the same page, which I know can be kind of difficult with this editor. Like, for instance, I won't be able to zoom in any further than that, so if that's small, probably better off pulling up your own copy of it, which is now in the chat. But otherwise, yeah, let's crack on with question 2. E to the power of 2x minus 12 is equal to 4 e to the x. We're solving for x. What could we do?
Make it into sort of like a quadratic situation.
Yeah, make it into quadratic. Absolutely. What's
Like
that going to
make
look like?
e to the power of x as like a or something, like a be e to the power of x.
Very good idea. Yeah. So we'll say a is equal to, so we have a squared minus 12 equals 4a. And then, yeah, how do we go about it from here?
Oh, sorry, let me just open up your
Oh,
you're doing
sure.
real quick.
Yeah, no worries. Take your time.
Obviously you would want to bring 4a to the left side so we can equate the whole thing to 0.
Yep.
And then looking at this, we're gonna get like in factorized form it's gonna be a minus 6 times a plus 2.
Sounds good.
And that means that a is equal to 6 and negative 2.
That's good.
And
Smash it.
that means e to the power of x is equal to 6 or negative 2.
Yep.
And let me just look back at the question real quick. Okay. We're solving for x, right? And that means
hmm
oh no, we had to do into like a natural log, right?
Yeah, it's going to be a natural log answer.
Is this x is equal to natural log of 6 and natural log of negative 2?
That would be converting both to natural log, yes. This would not be the final answer, though. I won't give any hints as to why.
Is there something to do with the negative log?
It is. So, as long as you know to get rid of it, that would get you the mark. Although, just to see your understanding of it, why can't we have a negative? Like, what's going on there?
Um, Correct me if I'm wrong, but I think logs don't have negative solutions.
Yes, you can't have a negative in the bracket of a log. And there's a couple of things you could point to. One being the fact that the natural log just looks like this, and so it's only defined for positive in the brackets. So I guess one thing you could say if you needed to say something would be that it's just, see, the problem, I think in methods you get away with calling this non-defined. Technically the answer is non-real. And that's because when you do spec, that does have a solution. It's a complex number, or an imaginary number rather, and technically you would consider that a non-real solution. But that's a bit of a semantics thing. We don't actually really cover that in methods, so if you just say it's undefined, I think you'll get away with it if you had to. But to be specific, The possibilities are when you have a negative, that would be considered non-real. So non-real. And when you have 0, that's undefined. And that's because only 0 is the thing with the asymptote, right? Like logarithm has an asymptote for x equals 0. That's what makes it undefined. Whereas for negatives, there technically is a way around it, but you get into non-real solutions.
Yeah, cool.
That's that. I mean, since you're only one here for now, I'll let you actually pick out if you want to do a question or if you wanted to skip it. Because this one is just sketching a hyperbola. Is that chill enough how you would go about that?
Yeah, this should be all right, I think.
Yeah.
But someone's just doing so maybe like if they want to.
Yeah, that's fine. Um, I mean, I will ask a follow-up question for it anyway, which is to get, assuming you do now have this graph, using that graph would be kind of nice to have to figure out where f of x is less than or equal to 1. Simply because if you just try to solve this algebraically, you get into some kind of issues around what you get as an answer, if I remember correctly. Yeah, having the picture does sort of help a bit. So let's at least maybe walk through the broad strokes of it without really doing too much solving. How we're sketching this hyperbola.
Horizontal asymptote at y is equal to 2.
Yep, vertical translations too, so that's going to set our horizontal asymptote at 2.
Vertical asymptote at x is equal to 1.
Yep, that's good.
And then since it's a negative, there's gonna be a curve in the top left and
Mhm.
one in the bottom right, and then let me just quickly solve for intercepts.
Yeah, sure. By the way, Pia, can you see the PDF that's in the chat there? It's a copy of um, the actual document. So if you need to zoom in at your own level, you can have a copy of that.
I can't see it.
Can't see it? Okay, let me drag that in. It's weird. I thought I had a persistent chat for these, but I guess it's just for me. Interesting. Anyway, that should be in there now.
Chris, is the x-intercept 5 on 2
It is. Yep.
and the y-intercept 5?
5 on 2 and 5. Yep, both of those are correct. And then, yeah, just for the sake of like how we get there, it's just going to be subbing at x equals 0, y equals 0. That does boil down to how you would solve a linear effectively. So, unless anyone wants to see the working out for that, I think better off now having a look at part B, which is a bit more, slightly more challenging, trying to figure out an inequality. And as I said at the beginning, using the graph to help you out with this will help out a little bit.
Chris, is this for all x values um from like x4 to in positive infinity?
That would be going the other way. So you'd be doing greater than or equal to 1 if you were to do that.
Oh, this is left hand, sorry. Yeah, my bad.
Yeah. And if it was greater than or equal to 1, you would actually have more answers because you'd also have the top
No,
left.
yeah, I was about to get onto that.
Yeah.
Yeah, I was gonna say then what like from negative infinity to one, but one is like non-inclusive.
Negative infinity to 1. Okay. So negative infinity to 1 would be everything up until here, which means you're hitting these values, which are, well, by definition, they're definitely greater than 1. This one's a less than or equal to 1. Did you know you're trying to go less than?
Yeah, no, I just realized
Yeah,
I was
okay.
thinking then.
That's fine. So yeah, this is why I'm saying like using the graph can be kind of helpful because one thing you can do is literally just say, well, one's about there. And so if I just sort of chop that off, I know that I have to be underneath this line. I want to know where my curve is at or below that line. And getting to 4 was good, yeah. So that would have just been saying let 1 equal the function and then solve for x.
So is it just 1 to 4?
Yeah, it's going to be 1 to 4. Now, what kind of brackets are we using there?
So one is gonna be non-inclusive, so the round bracket, and then four will be the square bracket.
Yes, it will. That's it. So yeah, you'd say something to the effect of x is an element of 1 to 4. Even if you just give 1 to 4, you'll get the mark as well. But this is slightly stronger. And then yeah, the only real thing to do was solve the x equals 4 by getting y equals 1, just rearranging that. Why I pointed out that solving the inequality without having the graph might have been a bit of a pain is if I change my screen share over, how you would actually solve that inequality would give you you'd have to think about it a bit harder because you would set it equal or less than equal to 1, you would do your rearranging, and then you would get here where you've got x is less than equal to 4 or 4 is greater than equal to x, which, well, obviously not super good because you want to cut it off at the x equals 1 barrier. So that's why typically using a graph to help you out will be a good idea. Anything to dive into deeper on that one? If not, we'll have a look at question 4. Trapezoidal rule. There's a couple of ways you could do this. This is a not a bound reference thing. This is a formula sheet thing, so you do get access to the formula for it. But there's also another way of going about it, which is technically the same thing, but has a different feel to it. Anyone stuck on how to start the question? These are fairly lengthy too as well, just from the sheer calculations you do. 2 marks, so you're looking at 3 minutes total to get everything down. It is a bit of a time waster question.
Chris, is this 25 on 3 units squared?
25 on 3 is a little bit off, unfortunately. What approach did you do? Did you try to calculate each trapezium, or did you do the trapezoidal rule formula?
To be honest, I couldn't really remember the trapezoidal rule formula, so I just did the draw the trapeziums out of the graph.
Sure, no, that's fine then. Let's see what could have gone wrong for that. So the heights that are involved there. That's the first thing you'd have to try and find, setting up your trapezoids. So let's have a look. We have function, curve, have 1 to 3, so we have 1, 2, 3. They're supposed to be equally spaced trapezoids, which is why it's going to look basically like that. And so trapezoid area formula, what's that?
It's like the A plus B, which is like the left and right.
Yeah.
So over 2
Yeah, A plus
times
B
the
over
height.
2 times H. Yeah, correct. So in the context of what we have, this is H, this is A, this is B. So at least for this specific trapezoid, when you move on here, this B becomes the next one's A and so on. But yeah, so we're going to have H as 1 across the board. A is going to be f of 1, because it's the function, it's the y value at x equals 1. B is going to be f of 2. And then, well, obviously just dividing by 2 there. H is just 1, so we can pretty much ignore that. So that's the first area formula there. Next one, the A value for the next trapezoid will be f of 2. And then the B value of the next trapezoid, f of 3.
Wait, Chris, just a question. Is it 71 on 12 units squared?
71 on 12, still a bit off again. You're targeting 31 over 6 is what it should end up being. So
Okay.
final answer should be 31 on 6 if you want to keep playing with it.
No, it's all good. I just want you.
Sure. And so yeah, these are the things we need. We need f of 1, f of 2, and f of 3. As far as getting those, we're subbing it into the function, which is x plus 1 over x. So we have function y equals x plus 1 on x. So f of 1, 1 plus 1 over 1, y of course is going to be 2. F of 2, 2 plus 1 over 2, what's that, 5 over 2. And then finally, so we'll call this y2, y1, y3, 3 plus 1 over 3, we're going to end up with, so that's 9, 10 over 3. Any of those were different to what you had?
I had those for the first one.
Say again, sorry?
I had all those values, yeah.
Yeah, you had them all. Okay. So let's see what's happening from then on. All right. So for A1, I guess we can even say like A total is now going to be F1, which we know is now 2, plus F2, which we know is now 5 on 2. That's going to be over 2. And then we're plussing that with f2 plus f3. So we have 5 on 2 plus 10 on 3 over 2. Each of those are their own thing. And that should end up getting us to 31 on 6. So right now we have fractions on fractions, not particularly pleasant. So best thing to probably do from here is take out common factor. Take out common factor of a half, for instance. 2 plus 5 on 2 plus 5 on 2 plus 10 on 3. It's already a lot easier because now you're taking out the divide by 2 and everything sort of condenses down into itself. We've now got half 2 plus 5 plus 10 on 3 because 5 on 2 and 5 on 2 make the 5. Then you need to go in and probably combine the 5 and the 2. So 7 plus 10 on 3. Same denominator, so 21 plus 10 on 3. So in total, you're looking for 31 on 6. So 21 and 10, 31, and then 3 and 2 to make the 6, which final answer. So if you try to simplify each of these fractions individually, you might have had a lot of effort to put into that. Is that what happened? Or
No, I just like realized I don't know primary school maths apparently.
no worries, no worries. Because yeah, this sort of approach is probably what I would start following to try to simplify what you're seeing, because these mistakes do happen regardless of how good we are. It's just how many of them by the time we do the actual exam is what the real difference will be. And so little things like this can help, but realistically it's just being consistent with how you approach lots of numbers. But yeah, that's about it. Anything to clarify from, I guess, just the overall approach of that? Because the actual arithmetic wasn't anything special.
Could you show me the trapezoidal rule that you're talking about, just for memory?
Yeah, sure. So trapezoidal rule is this equation here, xn minus x0 on 2n, and then you have the functions with the like the end values of each of them don't have a multiplier of 2 on them. Everything in the middle has a multiplier of 2. So because this only spans from 1 to 3, you have x0, xn, so x equals 1 and x equals 3, and then everything else in the middle that you do have values for, you double the f of x into. x0 is always the starting x value, that's why you have a 1 there. Xn is always the final x value, that's why there's a 3. And n is the number of trapezoids that you use. So we've used 2 trapezoids, we've got n equals 2. This is on your formula sheet pretty much as written, a little bit differently though because I had to generalize it. If we had to look at it, they wrote it this way, but you can see the similarity. Xn, x0, 2n, x0, x1, x2, everything else in the middle is now doubled, and it's just on the outskirts that are a little bit off. Well, at least they're not double. Cool. So yeah, nothing you have to actually memorize, it's just there for you to use. All you have to do is know what each of the letters are. Okay, integrals. Yeah, why not? Yeah, these will lead into each other anyway, so I guess it'll be a good one to start with to lead into it. Question 5a. Evaluate 0 to pi over 3 sine x dx. A half? Yeah, that was real quick. Did you tech active that? This is a tech-free SAC, by the way. That was no CAS, and you did it that? Oh, how did you... That's brilliant. How did you get it fast then? Oh, you've seen the questions before. Sure, okay, fair enough. Yeah, okay, no worries. I thought you might have had like a little cheeky thing that you were able to see because of how sine is yeah, that's what I was saying because I thought you might have seen like a symmetry of it because how sine is periodic when you do these like definite intervals over certain durations, you can kind of tell what the value is going to be. Like for instance, whenever you would do a definite integral over an entire period, you just get zero because well, assuming there's no vertical translations, because you just get the average of it. You just get zero. And I thought you might have seen a, a little shortcut like that. But no, fair enough. Yeah, so if you've seen it, I think both of you probably chill with it then. All you're doing, anti-diffing the function and then subbing an upper and lower bound as per that. So yeah, if you just want to hack in the half for that, then use that for the next question by all means. This one's fairly involved. Is anyone having trouble starting it?
Chris, is K?
Mm.
Hold on. Actually, now that I just seen the domain, it could be like multiple values, right?
It can be multiple, but I'll give you some confidence if you can give me one of them. I'll tell you whether it's right or wrong.
I was about to say pi on 6.
That is one of them. Yep. So you're on the right
Then,
track.
so then that means it's 5 pi on 6 as well.
Yep, that's another possibility.
Let's see, it will be negative 7 pi on 6
Yep,
and negative 11 pi on 6.
those are all good. Yeah. So as far as starting it off, hence or otherwise pretty much implies that you probably should use the previous answer to help you out. And the thing you would have noticed there is that 0 to pi over 3 of sine x is what we just calculated. So instead of having two integrals equal to each other, we can now just say a half is equal to that integral. Was that the approach you used?
Yeah.
That's good. Because otherwise, yeah, there are other things you can do. And then, yeah, so now it's just, hey, here's an integral that equals a half. So we do our antidiff and sub in our upper and lower bound. After a bit of rearranging, it's pretty chill. Just where does sine equal a half? We're given a certain domain for it. So you're just going to solve all the possibilities for where sine equals a half. And those are going to be what he said. Anything to clarify further on that? I'll throw in a sneaky idea if there's nothing to clarify. One thing you could probably do as like the otherwise approach is you can use the symmetry properties of sine and cos in the sense that you could like rewrite cosine as, now I'm gonna have to remember which one it is. One of them goes to pi over 2 plus x. Let me figure it out again. So I think it's sine x plus pi over 2 is the cos x. Yeah, okay. So you can replace cos x with sine x plus pi over 2, and you can use the translation properties of the integral to just sort of shift what the original integral looks like, and then map k onto that. Now that I'm saying that out loud, that probably only gets you one possibility, so still not a great solution. but something you could otherwise maybe consider as another thing in the tool belt. It's not really great though, just an idea to chew on. Okay, that sampling and estimation stuff. Cool. Yeah, some of these questions you would have seen in my notes. Well, technically all of them you would have seen, but yeah. Not sure. Have you checked your the formula sheet at the back? That could give you a bit of a hint. Otherwise, I'm happy to sort of verbalize the hint if you've already seen that. Let's recap what we actually have. So we're told it's a 95% confidence interval. We're told the actual values of our upper and lower bound. So rather than trying to calculate our confidence interval, we're told what it is up front. What we want to do is get p hat from that. Whenever you're trying to solve a variable, you need to find equations either in your formula sheet or otherwise that have that variable in it. Now, ideally, those equations should also be corresponding to the key information that you have. So one of the things that will be important to do is to say, hey, I have a confidence interval. If I look at my confidence interval equation, I can actually see there's p hat in it. Right, so you see p hat plus something, p hat minus something, and even those things have a bunch of p hats in them as well. Now, confidence intervals are always, yeah, I'll just kind of give it. Well, before I go any further, does anyone have any like hints or leads they want me to verify? I've got a written up version of this that I could show. I just don't want to give it away unless you're fully out. All right, cool. So this is the scenario where you have an interval and you need to determine your p hat and n from an interval. So what a confidence interval is a range of possible p hat values that could contain your proper population proportion. And your point estimate p hat is always the thing in the center. So whenever you're given an interval, you can always figure out p hat just by doing a midpoint equation. That's fundamentally it. Now, if you then need to go and figure out your n value, if it's also not told to you, then that's when you can use your whole confidence interval equation to calculate that. If you're 95% confidence interval, then you're using z equals 1.96. Although because this is tech-free, you wouldn't really be required to do a 1.96 thing of it. That's more so for a tech active. Because yeah, there you go. So they say use z equals 2 to simplify things a little bit better for you. But in tech active, you'll be using 1.96. You would see that all the p hats would disappear because you have p hat, and then all you would have to do is either CAS solve for n, or if it's tech-free, of course, just rearrange for n. So all in all, when you have a interval, you can figure out the p hat and n value, and even the z value in some circumstances, as long as you're given something else to help you with that. So if we apply that here, what are we going to get? You might as well do A and B, I guess, because I've kind of shown you both for that one. Add the yeah, correct. That's your midpoint. So you add the two values, lower and upper, so 0.04 plus 0.16, and then you divide that by 2. Yeah. So p hat's going to get you 0.1 for that. And then for part B, sample size, that's going to be using that other equation that I showed you. You use either the upper or the lower. It's good practice to have a look at your, rather than like copying directly off of the notes that I've got, good practice to have a look at the formula sheet, because you'll need to be able to interpret what's on there. So see if you can use the formula sheet based on what I've just discussed to solve part B for that. Sample size. Yes, correct. You're going to use the approximate confidence interval. Yeah. You have the full equation for that. You have upper and lower that you can work with. You can pick either. So if you pick the upper, you'll do the Z plus version of it. Whereas if you pick the lower, you'll do the Z minus version. Either way, whichever one you choose, you'll have a Z value, you'll have a p hat value from what was calculated, and you'll have, is that it? Yeah, those are the only other two things in there. N is the last thing that you can now rearrange for. The arithmetic on it can be a little bit tough. See how you go. It is a 2 marker as well, so I guess your pace should be 3 minutes to get it. 1.5 marks, 1.5 minutes per mark. So I guess that can be a nice little indicator as to like your overall pacing on it. Once you know what the approach is, how long does it take you to get to the final answer? This one's probably one where you might lose time on, just because there's a lot of effort that goes into simplifying the arithmetic. But you'll speed up your, like, I think question A was supposed to give you more time, because once you know that having an interval gives you p hat off the bat, like you solve that in like less than 10 seconds. So you'll find there's times where you'll definitely save up a lot of time and spend it on questions like this to bank. You'll bank that time for questions like this. If one's fully stuck, let me know. Happy to jump in. But if you are just working through it, happy to let you do that as well. You got 100. Yeah, I think 100's good. Yes, 100 is good. Nice. Winner of the race. Let's have a look. So this may or may not be super helpful. Just a little bit of an insight as to how I break things down to make them easier to solve. Let's see what I've got going on here. So I chose a lower bound, which just means plugging some things in. Simplified decimals in there. 0.1 times 0.09. Usually it's better to do fractions, a bit easier to work with than decimals, at least in my opinion. Then from there, obviously these all condense down into each other. Same denominator for this one. Divide everything by -2. Square both sides. Yeah. Nothing overly crazy there, I don't think. Part C is in my notes. I did talk about it as a theme that comes up somewhat often, oddly enough, where they'll there's no like formula / calculation for it necessarily, but they'll just get you to try and interpret what happens as you change things. That's what this question's all about. So it's still confidence intervals, so you know that using stuff from the confidence interval equation would be appropriate. But it's not one of those things where you can just say, oh, it's that question, so I do this formula. You have to do a little bit of arithmetic to get there. Have a think. If you're fully stuck, let me know. That, or pull up my notes on sampling and estimation, and you'll see this exact question in there. Would be 1/4. Can't find a way to spin that. No, not quite 1/4. If you want to have a chat about it, what were your thoughts around how to get there? I'll see if I can point you in the right direction.
I don't know. I was just having a guess because it just looked like it could be that.
Yeah, so you probably saw like we're 4x in the sample size, maybe it'll shrink the width by a quarter.
Yeah.
Yeah, okay. It's a fair estimate. I will say, have a look at, as a little hint, we're using 4 times the sample size. So if you pull up your approximate confidence interval equation, Start by defining what the regular width would look like, and then look at what would happen if you then replaced that n with 4 times n. See if you can then rearrange things. So if we, I won't scroll too far though, because that'll give the full answer. But basically, the width of a confidence interval is always given by the z square root term, right? You have a plus version of it, you have a minus version of it. So essentially 2 copies of this gives you the original width of your interval. Compare that to what happens if you put 4n in this spot. Do some rearranging to make them easily comparable, and then see what you arrive at. I'm keeping it mostly vague so you can see if you can arrange it yourself. If we're still stuck, just let me know. I'll show the full solution. It's probably a light separator question. It's one of the 1 markers that is significantly harder than the others. Though I will say this one in particular isn't so hard as a separator question usually is. It's kind of like 3/4 of the way there. And by separator question, I just sort of mean they'll throw these little 1 markers in there, make them really hard, so it makes it easier to separate students. Yep, that's okay. So the overall approach that I was describing is as follows. So start by defining what your original width is going to be. We have basically no information about like n, p hat, any of that stuff. So we can just use stock standard, the entire standard deviation term to help define our width. As I was saying earlier, because the width is given by the z p hat square root, that all stuff. In fact, it's given by 2 times that because you've got 1 on the right and 1 on the left. So whatever your original width is, it's going to be based on 2 times this standard deviation term. Then the next thing I suggested was you see what happens if you replace n with 4 times n. Now, if you just compare this to this, you can't really say a whole lot just by looking at it from here. If you're sufficiently skilled in methods, maybe you might see off the bat what this simplifies down to, but I wouldn't see it off the bat. So one thing you want to do is try to make it in a more comparable way. You want to try and rearrange it so it looks similar to this. And the way you do that is to take the 4 out of the square root. That'll make it become a half. Your width, your second width is now just z times that square root term. If you compare that to 2 times that z square root term, suddenly you see the difference. All right, this is reduced by a factor of 2. Now, if you just give factor 2 or factor a half, you're really pushing your luck on it. You'd want to say whether that's a decrease or an increase, because the question isn't overly specific. It just says, by what factor will the increased sample size affect the width? So it says affect. It doesn't say by what factor will it increase, by what factor will it decrease. It does say increase here, but it's referring to the sample size being increased, not the width being increased. So because it says affect the width, you would really be better off putting whether your factor is a decrease or an increase. So there's basically two ways you could produce that answer. You could say decrease by a factor of 2 or increase by a factor of half, both of which would cause a shrink. Yeah, that's the overall approach there. These are actually in the notes, I think word for word, actually. Yeah, I had to copy the thing from earlier. This didn't actually end up mattering, having this information there. But yeah, it's the exact same thing that I pulled from there, because it's somewhat common for it to show up. But yeah. Okay, next up, we'll probably round out the rest of the lesson on this. Let's see how far we get. Question 7, range of f. Will even be a quick fire one, for part A anyway.
Is it -1 to infinity?
Yeah, that's super chill.
But I think because there's like the closed bracket, like the closed circle, is that inclusive?
It is inclusive. Yeah, correct. Yeah. So obviously, I'll give one word of warning on this, which would be make sure you look at your domain. Even if this does look like it's shooting off to negative infinity, they might be tricky and they'll say, hey, by the way, it cuts off at -100 or some bullshit like that. Just keep that in mind. Don't just look at the trend of the graph, look at also the domain that's associated with it. But otherwise, yeah, range, fairly chill. Where's the bottom? Where's the top? That's it. Nice. Sketching inverse. That's going to be tough to verbalize. Maybe if you just give me the endpoints and axis intercepts, I'll say that's enough, and then I'll just show you the picture afterwards. There's a couple of ways you can do part B as well. There's one thing you can do that can make it faster to solve B, but not necessarily faster for the overall test, which I'll explain once we get an answer for this. I guess I'll say there's a reason why it says solve the equation after part B. There is a way to do B without knowing the equation of the inverse.
Chris, is the like inverse gonna be like a root function?
Yes, yes it will.
Is it? It's plus minus root x plus 1, I think. But
Almost. There's one term that's missing.
and then there's like minus, wait, plus 1.
Plus 1 on the end, yep.
Yep.
So that gives you the algebraic way of getting there. There is one thing you'll also have to do to that to make it a proper inverse.
And then we need to switch the like what range and the domain.
Yeah, that'll help you fix the function. Yep. Because when you have plus minus on a root, that's not a function anymore. That's a
Yeah,
relation.
we need to reject one, and that means
Yeah.
are we rejecting the negative one?
No, actually rejecting the positive.
Oh, okay.
Because the range of our inverse is going to be the domain of the original.
Oh, I see it now as well, because we're reflecting in the thing in the line of y is equal to x, right?
That's it. Yeah. So if we put a picture to that, basically here, so you're reflecting in that line y equals x. That dotted line is your inverse, and so you can see how that would now be a negative square root as opposed to a positive one.
Yeah.
So yeah, that's one way that you could sketch that graph. You could get the function and then dot it out. The other is what we just described there, which is reflecting all the points. So you can take this endpoint that you know, 1 comma negative 1, and then the flip of that, well, you just swap the x and y. 0, 0 obviously doesn't really flip because it's already 0, 0. You're just flipping things into the same spot. But overall, you're just sort of following the same trend line there. That's what I was saying in the sense that you could sketch B faster just by using that, but it wouldn't necessarily speed up the entire test because you still, in part C, need to know the equation and domain anyway. So you do need them regardless. But yeah, just like you were saying, to put a bit more perspective on how you actually get to that answer, completing the square. So you've got this thing where you swap the x and y, but if you just try to rearrange for y, you're going to have a lot of trouble. And so better off completing the square on that because that gets you only one y to work with. So from there, continue rearranging. You'll have your plus minus. Then you got to match that to the domain of the domain of the original because that gives you the range of the inverse. That or look at the graph you just drew. One of those is clearly a negative root, the other is clearly not. Yeah, that's about it then. Anything to clarify from that one? Yeah, this is the last question on it. Let's see how far we can get. You'll have a limited time to have a look at it, about 2 minutes or so. See how far you can get. I'll jump in at the end to show you the process if we're not at it by then. And then yeah, we'll call it there once we have it. Dig in. I'm looking at my notes on this. There is a long way to do it, and there is a shorter way to do it. There's a significantly shorter way of doing it. I had 4 pages worth of notes to give for this. 1/3 square units. Let's have a look. That is right. 1/3 square units is correct. Good. And I like that you put a square units on there. It's a slightly, I would say slightly favorable answer rather. Yeah, cool. Let's suss out what was actually going on there. So, bound area between curves, the line y equals negative x. The thing to recognize is that the line y equals negative x cuts through those points. So that makes it a lot easier to figure out what your target bound area is like. We're looking for this green stuff in here. We don't have to go ahead and figure out those endpoints if you can already identify the fact that y equals negative x cuts through those. So if you didn't identify that, you'd have to do all this shit to figure it out, to, you know, make function equal negative x and solve. But instead, you can then do your bound area equation. Now, another thing to recognize is the symmetry, right? This area is this area. So instead of doing the addition of these two things, you just do one of these and then double it. So what I'm showing in the notes here is what the full thing would look like. Just split it up into doing one or the other, whichever seems easier for you to calculate. Probably this one's the easiest to calculate. Square root's a bit of a pain in the ass. So if we just scroll to what A2 looks like, that anti-diff gets you 1 over 6, and then you're doubling that to get the 1 over 3. I had a lot to talk about for this one, apparently. Look at all this shit. I show you the easy way, and I show you if you're not able to find those little shortcuts. Well, if there's anything to clarify there, let me know. Otherwise, this will be end of class, and I'll see you guys next time.
Thanks, Chris.
No worries.